I'm just starting to adopt this platform. Basically, nobody in the embedded community have any like good whatever. So the point is that they do not like ESP32s and Arduinos, so they actually prefer STM32. That's the professional shit. So today what I am actually doing is that I'm figuring out what a voltage regulator or voltage divider are, which is basically a device that you use to make with two resistors, and basically you hook them up parallel and you connect. We'll show you first. I will now measure this, but what the concept is that we use two resistors in parallel with 5 volts, and basically you make so intro pressure sensor, pressure transducer, whatever they call it. You basically provide 5 volts through its legs to him. But the problem is that this will output 5 volts or 4.5 volts at max, and if you have high enough pressure in it, it can put out 4.5 volts max. And that will damage this 3.3 volt core voltage device like the STM32 or the ESP32, whatever you have. And for that you basically take this, which is a resistor, and you divide it so that the 5 or 4.5 volt whatever the output voltages will be always divided by this number, which is 0.6ish. So you put it into the code, and when you realize at 4.5 volts it should supposed to be 3 volts. If you read slower, let's say, I don't know, 2 volts, 2 volts is going to be 2 volts times 0.6, which is 1.2 volts. Or is it when we read 2 volts, then it is supposed to be divided by 0.6, so it's 2, that's a shit. Let's say 1.2 volts would be to give 2 volts at this voltage, whatever. So we do not want to damage the guy, so therefore we reduce the output voltage proportionally, and that's the divider's job. And I have no clue how it is basically, or I mean had no clue, now I have a better clue. Mark these. I think these are connected. Can't reach in. You have to do this like so. How do we do this? I think like so. All right. I think they are connected in like this. So I think one row is supposed to go. One row is one. They're supposed to be connected. I do not know how the internal rails are actually. I would be surprised if it is not going to connect. If I could fucking put the device, yes, they connect. So basically, towards these are the rails. I think if I put the two shit onto the two side, I will not have anything in the middle. I think it is. They are safe on the two sides. We'll check. I will assume that that's the case. Just going to test if it is. Yeah, it seems that they are fine on the two sides. Alright. So we have the little good old pressure transducer here, and we will provide him the 5 volts that his soul requires. And I mean, yeah, this doesn't look too good. Oh my god, this is so shit. Shit, fuck. Oh, god damn it. I will need to lay on the floor because I have nothing on the fucking table left, no space there. So weighing ground 5 volt. All right. Ground. All right. And we have the signal that we are. You know what? What I'm going to do for first, I'm just going to provide the same thing. If you are not familiar with these things are the STM32. I always want to say ESP. So these STM32s are kind of similar to the ESP. The only thing they are a bit dumber in that sense that they have less flash memory and all that, but they are actually smarter, that they are more configurable than the ESP. So yeah, and they have more pins, 5 volts. Basically, this is a Arduino style header here, so you can actually use like one Arduino to connect here, and it's kind of like a shield. Basically, you can stack it, and that is pretty good. You could use like an Arduino as a shield, and the good thing is that you can actually have these pins here, which are this one, this slide, and this line. These are basically the same as this. They are internally linked to the CPU, just as the Arduino style pins. So if you have male, female, you don't need male pins to connect to the breadboard, thank God. So +5 comes here, and +5 we have the ground here. Oh, this is not good. I need something. I need a towel or some shit. So alright. Alright. Oh. This is better. Yes. Oh. Oh. Yeah. So yeah. Oh, fuck off. Alright, so this is supposed to be the ground, if I am correct. And how this is supposed to work is that I take the leg and I put in the 10 volt bullshit, which is the bigger one. The 10 volt guy will come here, and I will, you know how big this is. I guess we can go like something like this. Something like this. Put a rope. Can we put it in there? No, of course not. Alright. It goes in. And it goes somewhere along. Have no clue. Maybe. Or maybe this is not a good idea. Make it equal. Long. All right. So we put the 12, this guy here, the 12 volt, the 10 kilovolt, 10, fuck me, so 10 kilo ohm resistor there. These are 1%ers, so pretty accurate, and the 15 kilo ohm to the ground. So they're supposed to be in parallel. Alright, this is a very tiny one, but we will do this nicely. Please do not bend or buckle. I mean, come This is a bitch. Fucking breadboards. Alright, go in. Little Johnny. Alright, Johnny. Now we are in. This is a terrible shit idea. I fucking hate this. Alright. Now that we have this, we will need a ground wire which will connect to here. And fuck off, view. As if the ground wire goes here, then this shit goes here, and we should be able to get the analog voltage from here, and should be able to take down. You retard. Whatever, this is fine as well. We will be able to, if I did everything right, we should be able to see the I don't know where the pin. Of course the headers are not in the right way. Of course. Whatever. So I mean, we can do this. So we connect this. Goddamn you. This is a fucking bad shit joke. I hate these little garbage ass pins. You're really fucking kidding me. Something either is shit or I have no clue what's not okay. Hello? $200. Oh, I know, I think I know why. I think I know why, because the resistance is too big. Even now, yeah, this is either shit or... Do we have anything here? From here to here? Here to here? Yes, 15 ohm, okay. Does this have anything? Maybe this is the problem? Breadboards, fuck me. Please work. Fuck you, man, like, come on. Thank you, rooms, alright. From here to here, 15. But why the fuck does this not have this? You little bitch. 27. Oh, because it was bigger than that. Alright. I mean, in series, they're supposed to be 20, 25. Alright. 24.7, that's okay. To here, it's supposed to be... what do we have? If we connect this parallel, then to this, it's supposed to be let's see. Let's test this shit. Maybe with the STM or ESP. Maybe with the ESP32. So we do not fry this. I don't want to fuck him up. Well, I don't think I will. Though I do not want to. Do I want to risk? The problem is that I will not be able to do it without him, so I will need to rely on him. Despite all the heartfelt. Oh, yeah, well, almost got me, bitch. Way in. This is ground. This is ground, and that is going to be the 5-volt pin. Alright, I'm not going to put the other one back there. You bitch. So, yes, we have both of them here, which is fine. What I'm going to do is then I am going to power the guy up. If I remember correctly, this is supposed to be alright. If not, then I don't know. Hope for the best. This is supposed to be okay. This is not a fucking Houdini bullshit here. This is supposed to measure like of course it is on the right fucking side or on the wrong side. Bitch. I mean, yeah, I have an idea. So if we take this, we take this and put it here, we will be able to measure the voltage across these two bits. And now take off my pants. No, I'm just kidding, but need a cable. Where is it? Okay, we have the cable. Thank God, I think it's even long enough. We'll have to pull it a bit to the side. What I will do is I will take off the, this is not the best tactic to nail. Yep. The other is, maybe this is not the best idea either. I mean, fine. Yeah. Let's see. We'll put this in here. Hope for the best, guys. Hope for the best. Or should we do this with this? Fuck it. But I can't. That's the point. Oh my god. Alright. Let's hope for the best. I don't think we are going to fry it, but should we not? Because this is how it's supposed to be. We go 10 volts to the yes, and we take the on the middle pin. Yes. What? Okay. 2.9. Let's see. I will check one more thing, but I'm pretty certain that it was on the same morpho pin. That's the middle pin, what it is called, on the STM32 446. This is it. Oh fuck. Is it? Yes. Alright. 5 volts. Alright. Okay. 5-volt pin is 5-volt pin. Yes, sir. Ground is ground. Alright. Ground, vein. Okay. So it's the same. It's the same thing. It is exactly the same thing. So I will just one more thing before I don't want to fuck the board up. I don't know what I'm doing. Very simple. Then I will So basically, we will have this pressure voltage divider for now. I'm a bit uncertain. Oh, come on, man. Not again. Fuck. How do we do it? Then we go to pin, pressure transducer, V, ground, and the thing. How do we do it? So we wanna put the thing here. Measure the middle node to ground. It's 3 watts, but roughly 2.94 should be. Towards. Yes. Alright. So this is supposed to be alright. This is supposed to work, but we will see. Now the moment of truth. Here comes the smoke, hopefully not. Alright, so we shall see something along the line of brown to blue, a 2.8 volts. Great, I'm happy with that. 2.8 volts. Alright. 2.82. Okay. 2.82. Okay. So the pressure transducer will work in a way that we will put these. We will put these the guys, the G's 2.82, if I'm correct. 2.82. Right. Okay. So how are we going to do this? Fuck. First, oh hello, I am Mr. and I'm testing out the pressure transducer, and now I just have made a voltage divider with these little tubes. Oh, it's a bit far away, so I might as well just pull it closer to me, because it's far-fetched thing. So this is it. So again, it's not, now it's too close. Alright, so we have these. I do not need this anymore. Yes, I do not need this. What I will need is that, how the fuck do we do this? So if we have a, what's this? Oh fuck. Oh, thank God, this has this pin. Alright, okay. So we have the 5 volts and the ground. I'm going to connect them. So V in, ground, 5 volts. Alright. Ground. This goes to the, how the fuck does this work? This is the power, so this goes here. The ground goes to here, common ground. If I am correct, V in, ground. Okay, and then this should be able to connect here. The ground to ground. This is the ground. To craft. You do not have a. Yes. Alright, ground to ground is good. Power goes here. Alright, and the analog goes here, and from here we should be able to take out the 3.3 volts, or what do we call this, the not 3.3 but the reduced voltage, whatever the signal line is. That's the problem. How the fuck do we do this? Oh, we will have to put it to the PA. So take this, and actually can put him right back here. Yes, right back here. Okay, and ground to ground. Fine. I mean, we'll check everybody, so we have like connection. So this is the fuck. All right. Ground to ground, it was good. Or is it? Okay. Power to this, this, this. Okay, nothing. Power to this. Put. Okay, great. Okay. We take this out here. Okay. Alright, we should be able to detect a something along the line of, I don't know what the basic pressure is or voltage output is. PA, it's supposed to be connected to the PA. Ground to this, power to this, and going to put on the should. Oh, you know what? I'm not going to connect it. I'm just going to measure out the voltage. So yeah, let's do that. Let's just do that. Hopefully there will be something, because when I did this test first, there was nothing, because the pressure transducer requires 5 volts or 4.75 at minimum, and I used 3.3, so it didn't work. It didn't produce any measurable voltage. I just set it to, I believe it will be lower than 2, but we'll go with 20 volts first. Alright, so hello. What I'm going to do now is that I'm going to hook this up, just the power lines, the what is this, the, hopefully the smoke doesn't come out, right, power is on, and we should be able to read the multimeter a voltage to here of a about 1.5, 1.50. Okay, great. Okay, 1.5 volts. That's pretty great. All right, exactly 1.5. Go with the more high resolution. So go with the other one. 1.53. 1.53. 29. No, fuck off. 1.53, 29, 28. Okay, I think that's pretty nice. Okay, alright, alright. Alright, hook it up to the 1.3, 1.39, 5.3, 1.539 at the between GND to logic output. Now I will download hooked to this PC. Then I think our ADC is gonna be alright. Might I have a few more caps that I have bought because I have seen the pressure transducers drawing at one day. We'll find it. What is this? What do they call this? King. Alright. Alright. Back. Right, I'm in. Alright. MPX. This is a 7002 if I'm correct. Fuck off. DP, by the way. So a 2 kilopascal differential pressure transducer pressure sensor, if you will. Great. We'll need this PX free scale. What the fuck is this? Does this have any? Does this have any? No. OH. No, fuck you. Where is the description of the device? Okay. Alright. I have seen something along the activities. So we should take the 5 volts and put it to ground with a 1 UF and a 0.01 UF. Okay. I think that's 10. This is 1110 nano, 10 NF if I'm correct. Or that's pico. GND, I think that's pico. 10 AF. I really hope I did write the right. I might have fucked up. I have bought a. Oh fuck me. I have bought a 10 NF. I think that's supposed to be a fucking PF. God damn it. Fuck me. 1 UF. Alright. Oh, fuck. I have a few. I only did buy 2. That might have not been the best idea. Whatever. I am just going to. Oi, oi. God fucking damn it. These are too small. Or, oh, is it? Fuck, they have long legs. These don't. These are small as shit. These are small. Somebody has some DNA. Alright, fine. I have these. By the way, I have this 16-bit analog inverter or analog digital inverter module here as well, or converter module. I square C. We'll come back a minute. I have set this up. Actually, I've put on the pin end to it. and now I will hook it up. Oh, of course it's on the wrong side. Come on, go in. Okay, so PA0, which is this, if I'm correct. PA0. Alright. So I will now download the putty, whatever. So if you are, I don't know if you know about something about like STM32, this is a kind of similar to ESP or Arduino. It is a more industrial board. It has a better configuration possibility than just as ESP and Arduino. They use it because you can basically, there are this little chip here, this, you can actually configure all of its legs. You basically, if you don't enable it in the, there is like a, whatever, I'm going to show you if you can have the patience. Plug this shit. I will launch the app for now. QDMX, STM32 QDMX. So you can configure the pins on every single leg, and not all of them, but mostly all of them are almost good to anything. Basically, there are a lot of ADCs, so analog to digital converters, which are very useful because of these things, these little things. This is a pressure transducer, just you don't see the two pins on it here. So I don't want to twist because the shrink tubing here didn't really clamp onto the legs, and I'm afraid that they will break down. We'll have to lighter it a bit, but that's for later. So, but the main thing is that this is actually here, and now yesterday I have actually did a test with a pot meter that I have adjusted, and basically I have hooked it up to the 3.3 watt output and the middle to the PA0, which is an analog read pin, and basically read the pot meter's raw voltage, or the, so to speak, raw voltage, because it is like divides the voltage, whatever. So yeah, I was able to do that. Now I have set up the pressure transducer, which I will read the pressure for this bad boy here, which is the what is this? The homemade, so to speak, blower, which is completely done and working. Here you can see that the impeller is there. I have also made a rim. Sorry, the camera is dropping. You would see. Bad. I'm sorry, I'm a bad cameraman. So here there is this device that will be able to measure the output amount of air that the blower can produce, and we will supply it later on to the burner, but I do not know how much air it can produce on what duty cycle, basically what percentage, and that will be determined with this little pressure transducer. But back to reality, we need to first configure the board, so then we can measure the pressure later. For now, I have set up the divider so that the pressure transducer puts out a low enough voltage so that we don't fry the board. And now I'm just going to download putty to the PC, which is basically a program that is like a console that will write out the things that the little board sends through the COM port of it to my PC. Come here and putty. I will download this. This looks pretty shit, not gonna lie. It kind of looks. I thought first they were going to steal my data. It looks like this. It's not too good, not gonna lie. Oopsie doopsie. Maybe I'm just going to swap my camera so that I can see what I'm looking at. So this is putty. Doesn't look too how do you say this? Confirming, reassuring. Download putty. Windows installer. I think this is it. Yes. All right. I'm just going to do this. Going to show you if you are interested.
This is the CubeMX, and this is the first project on this PC. So I will just access MCU selector. I'm going to show you how the whole thing is done. If you have not seen anything like this, this is the brother little board, the ESP32, which is here. This is a Arduino style board. Basically has all the things that an ESP32 can do, has Wi-Fi, all the bullshit that you can imagine and ask for. Only thing is that the ESP is not used, neither is the Arduino in any serious design of, I don't know. What I am learning this for is just in the school that I want to learn it for a project that is to control a turbine, a gas turbine, a turbojet basically, and it has a lot of pressure transducers, temperature readers, all that bullshit. And I'm actually just learning the STM32 here, and I'm just a beginner with this. I'm not a big coder of this either, but I have used this to read temperature sensors, pressure sensors, all that bullshit. But this is not used in the industry because it lacks a lot of design, and it is not stable and not robust enough because it has Wi-Fi and all that bullshit going in the background, which is not trustworthy at all. So I'm just going to come here. I'm just going to say, I think, commercial part number. I don't know if I need to say it here. So Nucleo. Oh, oopsie. Nucleo. I think this is the other one. Control C. Oh, fuck me. This is harder than it looks with one hand. Control V. Please, come on. Nucleo. What is this? Wait a minute. I will have to put you down somewhere so that I can write here properly. And it's pretty hard to do this with one hand. So I put this maybe here somewhere. If it fits, it doesn't fit. Shit. Pretty bad, yeah, huh? I will. That's a nice commercial STM32. This is the F446RE, which is red. This, I think this. MCU or board selector. This is why I don't see it actually. So I need to come here. We'll show you. Commercial, I think Nucleo 36. This is this, and we need to now select. I will come back and do this manually. Sorry, very bad. Again, I don't have the quick draw. I will do the putty in the meantime. It's pretty fast. MX. Okay, we can do this. Blah blah. Alright, finish. 446RE. He is the guy. He looks like this. Start project. Yes, blah blah, peripheral bullshit. We'll have to do this, and we will. Here you can see the board. Actually, the little microcontroller on here. This is the same exact microcontroller as this. We can actually select out each pin here, which is very lovely, and we can configure them. So we have the PA0 here, which we will set to ADC in 0, and we will have to edit a few things on the logs. ADC1, which is basically here for us to read the analog data and convert it to digital. 12 bits we have to, I think this is the highest. I will also do another thing, which is this, I've also bought this is pretty cheap. It's called the ADS115M, which is a 16-bit analog to digital converter, and it sends signals through a square C to the board. I think this is right. Disabled. I think I didn't need to do this. I can't remember exactly what settings I needed to do. I might will need to edit it still. So if you give me a minute, I will need to get the code from the other PC, because I have already made it yesterday. I don't want to waste your time with writing the code here. So I will put you down somewhere I don't know where the fuck. There's no space in here. I have no space on my board. I've just set up both my PC here. Got back from the dorms. I will just show that what I'm doing maybe from here. I don't know. Just see my back. Going to come here and do this. I have no fucking space here. Where's my other mouse? Right, going to the cube ID, which is basically the cube ID in. First you don't find it, cube ID. This is basically the editor that we can do the code coding in, and I have actually wrote the code I will send myself with your email. I think I don't want to waste my time here. ADC converter voltage, both. Yeah, let's do that. All right. Test 2. I think it's even on. I think it's even on the. Yeah, I think it's even on the. I think it's even on there. What I will have to do is that I will have to figure out if there's a bit of fuckiness in the whole thing, because we supply it not exactly 3 volts but 2.8 something volts, which is going to determine us what we have to scale up the voltage bit. Alright. I'm cheating a bit because I don't know much about this field. I'm just a beginner in this. Alright. And the divider is consistent final time. Verify, sorry for it, I need to read this. Real voltage take 30 seconds, ground is exactly 3.3 volts, ground divided node. Yes, I have done this. 5 volt pin, 4.7, exactly correct. 4.7, 0.6. Yes. I suppose I should measure out the things. I'm just going to come here and do this quickly to check before I do anything. So not too interesting, but I suppose this is what we have to do. So plug the guy in. And now I will have to measure the voltage. Because we will need to know that the 5 volt is actually 5 volts. So that the 1.5 volts, we could actually see this if we could actually see it on the putty if I find the thing. I'll come back in a second. Putty. Alright, and I can show you what I'm doing here so you don't bore yourself to death. So you would see this is bad. Right, so what we have, device manager, which is all right. Now we open this device manager, we find the COM ports, we find the COM port 1, which is not this, we want the other guy. I want the board to show up here. And he port, okay, COM port 4, we put this to serial, COM port 4, baud rate for COM port 4, baud rate for, or speed, as they say, 115, 200, and we should be able to see something here. Here we go, 1.55, 6, 8, this is the voltage that it reads from the analog pin, basically from the PA0, which is that one, this blue. It's hard to see, but yeah, that's one. Yep, 1.5. This the ADC should not be looked at because, again, as I said, we should. This is the code for it. Basically, the raw voltage, which is the first one, or oh no, so not the voltage is no, this is good, this is the right one, this is the right one, or maybe I will have to check. Oh, almost close enough, not totally, because we need to do it with 2.8 something, and this is right, the 4095 is right. Basically, we take the reading of the ADC, which we read, and then we should be able to times that by what the supply voltage is, but this is not 3 volts, but actually 2 point something 8 volts. We'll have to measure it out. That's what I'm thinking. The ADC value, the 1029, pretty stable, 29, 28, 33, so I think that's pretty good. So yeah. What now? I will have to read a bit because I'm not certain what to do next. Might need to adjust the code, which will include. This is the problem here. This fucking utter chaos. Maybe I will put you here somehow if I do not. All right, this seems to work, but you can't see shit from here, right? This is a problem. I mean, I could come up from the PC. Fucking moving this, sorry. At least I'm just going to narrate what I'm doing here. Maybe this is a bit better. Let's see. Does it zoom in? No, absolutely not. God damn it. No focus. No focus. So I'm just going to read a bit and ChatGPT it. So 1020, what is the lowest? 23, and it goes up to 39 sometimes, but it's 23 and 40. 23, 39. So 4.7. The 5 volt pin is 4.7 volt. Not a divider problem. I think it's not about the divider. 1.353. Yes, okay. It's alive. 1.3 can be still valid. Need to confirm. V out directly to ground. V out. Voltage out directly to ground. Maybe what I will do is I will blow into the into this, and I will wanna see here, although I might not be able to. So we were 19 fuck off. 1931 and 1939, so about 16-ish, pretty, not the best with the ADC. What I will now do is that I will take my pressure sensor and I will find my tube, and then I will blow into the tube. First, fuck me. Yeah. So I will have to first go back here. I have to find a drawing of this shit because I do not know which pin is which. Alright. Who is who? Who is who? It's not this. It's this. Alright, then we go here. Who is who? Which pin is which? Where the fuck is the pin layout? Yeah, we are not better out with this. Still not. Who is who? Which one is which pin? Document. I do not care about that. Oh, come on. Sorry. This, I mean, this is peak, I don't know what this is called, embedded engineering, or I don't know what this is called. I have no fucking clue which one is which. I mean, meaning the pressure ports, because it matters. Sorry for fucking stumbling on my words. So it matters which you push the air into or which you blow the air into, because one is the always lower than the other one. I can't seem to find which one is it. Because this is supposed to be it, and I do not know which pressure. Where the fuck is the... Oh, I'm getting pissed off. There is like port 1 and port 2, but I don't know where is the layout. Yeah, this is the best experience. Yes, I know P1 is greater than P2, this is what I meant. So P1 is supposed to be greater than P2, but which one is the fucking P1? P1, great, thank you for this. And which one is which? For fuck's sake. P1 is supposed to be what we're supposed to find, but I do not know if we can find P1. Case, yes, dimensions, and which is which? Which is P1? Which is P2? Come on, man. Retail 8. Oh, fuck off. And this is a joke, is it? What is this? Come on, for fuck's sake. Fuck off. P1 is greater than P2. Okay, we have found this out at least. At least we know what which supposed to be higher. I still don't know which one is which. Great that we know. And this is important, I guess, because I will need to make this thing, but I would be very grateful if I could fucking
Two sides of the pressure sensor has pressure one side and pressure two side vacuum. Okay. Containing the gel dye. Yes. Protects the dye from harsh media. Great. And oh, side with port attached. Alright. Pressure one identifier. Side with port marking. What's that? Maybe it's the. Maybe there is. Footprint symbol. Oh, lovely. Device. Footprint. Yeah, I saw footprint. Yeah, I'm not better with that. There is one. Why is there no? Why is it not here? It's the same. Right, it's the same. Documentation is the same. God fucking damn it, man. Fuck you. What is this? Side port attached. Fuck this. What is this? MPX 722 VP pressure ports. Yes. Hospital bags. Yeah, right. I do not care. I care about which leg is which. Apply positive. Yes, I have seen that. Alright. Yes. Oh, there is a transfer function to do that. Oh, great. At least I have now learned something. Putty, is it still going? It's still going. Right. It's the same thing, I guess. Data sheet. Top view. Style case number. Not better off with this shit. Come on, man. Minimum rating, temperature, pressure, vacuum is the same thing, for fuck's sake. Port attached. What is a port? DP. Side with port marking. I honestly have no fucking clue what that means. Pressure one side identifier. Alright, at least this is useful. At least this is useful. I've also found this. Now, what I will do is I will drop this and we'll need to find one thing which is how the fuck do we identify alright, AI mode. have no clue. Dual port. Marking on the device. Yes, I see that. The text identifying the sensor. So fucking tiny I can't see jack shit. So I suppose that's the upper one. If that means that the side of the sensor that contains the part marking, the identifying the sensor, the text that identifying the sensor. This is also known the pressure side, containing the gel dye coat to protect the internal silicone. This port is on the side, high pressure positive side. Two and a half volts. Alright. Relative to P2 increases the output voltage towards 4.5. I will have to test one thing. Oh! Negative pressure. Applying pressure to P2 relative to P1 decreases the output voltage towards 0.5. So if I blow into the thing, it's supposed to actually not be as harmful as I think it would. Hope I don't do any bad thing. We'll cut the end off. This is peak experience. The total uncertainty is what we only have. Can no fucking flow. I'm learning these things actually in Zone, as you can see. No flow. So I have this pretty tiny silicone tubing because this little dumbass pressure transducer pressure sensor doesn't have any better. It has very tiny ports that you can connect the tube to. Oof. I can't even see this. Can I make it big? Alright. 1.9. Let's see. Something. 1.9. 1.935. 3,500. 3,500. Maybe I will. Now something? Yes. 367, 3668, 3656. Alright, I suppose that works. So this is, it seems that is the P1. What do we do now? So that's 3006. That's almost complete range if we think about it. Or 1.9, we go to 3,600 or something like that. Oh, can't screw up power. Alright, pretty good. Alright. So let's read a bit. I will read this up. Maybe if it is not totally readable. Pressure sensor output at 1.53 volts is a good sign. MPX 7002 type sensors, the output is typically around mid-supply at zero differential, often 2.5 volts when powered from 5 volts, but exact values depend on the sensor family and how you referenced it. Even your earlier it's alive behavior 1.53 volts can still be valid, but we need to confirm via directly. Yes,
to ground, or is that after the divider? What you want long term, measure sensor V out directly, first no divider, confirm it moves with pressure, it did actually. Then measure divider node, confirms sensor output stays at less than 3.3 volts. Alright, basically we did dividing from 5 volts to 3.3 volts ish, 2.8 volts or something. So yeah, I have the question, if we take it into account that the divider puts out 2.8 volts from 5 instead of 3. We have a, we can calculate this out quickly. What is this? 2.8 divided by 5, which is 0.56. Alright. Oh, all this dog shit. I'm gonna leave this. Don't care about this. Care about this. Alright, 0.56. Alright. And 0.56 dividing. And I have blown into the pipe of P1, and actually the raw ABC value went up to, what was it? Oh, I can't remember. 3,600-ish, something like that. So I think that is sync. What do we do now? So we have the divider working, we read the analog data well, we need to edit the code so that we can see the exact voltages rather than the thing, this one that I have there, the other one. So I have to edit this code. Yes. I have also a what is this? ABC to voltage converting and printing, but I suppose it's for this purpose, because the supply voltage is lower. So we have it float low voltage equals we have this, I think low voltage, this is 3.3 F dot F, I think, no, 3.3 F, because times float, and yes, ABC, close, fuck off, we close this, and then we divide this by 4096, if I remember correctly, 4095 actually, 4095, and 0.0 F. Change the frequency F to 2.8 F. the sampling should stay. There is another thing that I didn't talk about, which is actually sampling. There is like a how the whole thing it works is that the voltage is always sent to the ADC pin. It is constantly put to the ADC pin, which is this PA0. And if I want to be more precise, I don't know if it is visible from here. It is this one. Yes, so this one gets always like or sees like a constant voltage from the pressure transducer, and that means that the STM32 doesn't always convert the ADC readings from the voltage, but he or the analog data, he doesn't read it always, but he has like a sampling. He does, I think, 83, 85 times. I think 85 times or something like that. Sample size basically takes 85 samples, and then I think he does average them out, if I think correctly, but I'm not totally certain about that. I probably think that this shit can freeze out. I don't know why ChatGPT does this to me. It always does this. So yeah, now we are almost ready to test, which is very good. The other thing that I might want to do is to solder the 16-bit thing, this 16-bit analog to digital converter, but I don't think I will do that. Neither will I have the capacitors today. I think I will just hook the guy up. We'll have to check one more thing, which is that how the fuck am I going to connect the this tubing to the big ones? Because this is the biggest problem that I currently experience, is that I have no clue about how I'm going to do this. I do not know how to connect this. Just to give you a little context here, this, I don't know why this does this. Oh, thank God. So, just a quick context. There are these tubes that come out of the pressure. Why is there no focus? Fuck off. So, here's the blower that I will map out the production of air that it can produce for us at given PWMs, meaning that I send the voltage from that power supply to this rail. There is this two rails. There is one, I think this is the power, this is 12 volts, this is ground. We take the power to this board, which is a special board that I have made, and basically he is a chopper which does I will draw you something. So I will take a new board. So the chopper does one thing, which is PWM. I don't know if you know it, whatever. So I'm just going to quickly explain. So basically, he chops the voltage like so, and basically with it, you can, if you have like 10 seconds total, this is 2 seconds, and you have 2 seconds off, 2 seconds on, 2 seconds off, 2 seconds on, 2 seconds off. This is 4 seconds total on, and that means it is 4 divided by 10, which is 40%. 40% duty cycle, meaning that if you turn it on to 12 volts and you turn it off basically to 0 volts, and you provide this 40% duty cycle, you get a constant 4.8 volts, if I'm correct. 4 times 12 is 4.8. 4.8 volts. But this is not done in 10 seconds, it is done in 10 milliseconds or so, or maybe even more. You have like 25 kilohertz of You have 25 kilohertz of switching speed with these boards, because they have the capacity because they have an internal clock that can do this. So basically with the chopper you are able to chop, and you can set the voltage. You basically send this out to the motor. You have like a motor, and you can do from a 12 volt, you can do a 4.8 volt, basically adjusting it with the code. So if I type in, let's say, duty cycle to 40%, it sets to the duty cycle to 40%, and even if I put the 12 volt to the power supply, I just need to limit the amperage so it doesn't take up too much amperage. So then, from the power supply, so then at 40% duty cycle, we can provide him 4.8 volts. And why is that good? Why is that good? Because at 4.8 volts, you have like a linear thing, which is basically probably not looking like this because there is like a saturation thing, but if you take the voltage, this is voltage, this is torque or speed, you can split the speed, I think RPM in this, RPM, and basically as you increase the voltage with duty cycle, this is 100%, and it fixes out at 100% speed, you go to max revolution per minute. If you take it down nicely to 40%, which is here, then it's going to be 4.8 volts that you need to supply to get about 40% of speed. And why is that good? Because at 40% speed, you hopefully put out something like 40% of the total max output air that this shit can produce. And sorry, just yeah, I know. But if you can still keep up, we take this guy, and why we are interested with this 40% is that I will later want to fully automate him, that meaning that this shit is just, sorry. So this guy, or this guy, whatever, but probably this guy, will be able to fully automate him and adjust the output air that he can put out to supply the burner that I will have, which is going to be very nice. But for now, I do not know how much air it puts out per given amount of duty cycle or PWM, and that is this part of the thing is going to be for to measure out the pressure difference between the two things. There is an orifice plate here, which is a contraction, basically a smaller hole, and when you press air into here, and there is like a smaller diameter here, the pressure is going to be bigger here because it has to go through a smaller cross section. So it basically, you can imagine that the air is going to be slowing down there, and as it gets there, meaning that the static pressure of it will rise, and then here as it goes through, just like with a hose, when you put your finger onto the end, the water will, because there is less cross section that it can flow through, it will speed up and it will shoot further away, meaning that it has higher velocity there. That means higher velocity, Bernoulli's equation means that from a higher velocity the static pressure will drop, because we converted the static pressure from there to basically on that point we have static pressure converted to so we have the energy that there is before the plate, we have that, and from there we converted it to static pressure, which is going to create us a higher pressure there. But as we go through here, it speeding up reduces pressure, then the static pressure is smaller there, so there is going to be a natural pressure difference between the two. And the faster it goes, meaning that the more air it sees, the faster the air is going to go through that little hole there. I mean, not that little, it's 32 millimeters compared to 57, so it is a 0.6-ish contraction compared to the big diameter inside. As the more air you push through the whole system, the bigger the delta P is going to be between the two, meaning the bigger the pressure ratio is going to be. And that will be, the pressure ratio is going to be, we measure the pressure ratio if you take like a water column difference or delta H with water. You have like two tubes. No, sorry, I'm just going to draw it here. So you have one tube here, that is this U-tube, and you have like the two ports connected to here. This is the big tube. You have the two pipes here that come out of it. It's a bit shit in terms of looking like that, but you get the point that we have a higher pressure here, and it presses the water down, and here it has a lower pressure, means that it can go up because it can go down, and here it goes up. And basically there is going to be a pressure or a pressure difference, and therefore a height difference of water here, and the height difference of the water can be put into an equation which I have already defined, and it is, I think, 2.36 times square root of delta H of the water pressure, and that's going to be our not Q, which is the volumetric flow of the blower, and that's the whole thing of it. So yeah, I will now come back and continue reading, and I will, if you don't mind, take a break and get myself a bit of water because my throat is dry as fuck now. So yeah, I will take a few seconds. So until my cup is filling out, go up, and I think, alright, I'm done. Good old water. Still have half an hour left till I use the whole thing or finish the streaming. So I will take this out. Don't care about this. Putty will die, but that's okay. We do not care about him for now. We'll steal the code from the other PC and steal the code from this PC and put it onto the guy here. And alright, STM32 ABC 2V, or we are going to call it STM32, or is it fuck? We are going to make a complete different thing. This, yes, I know. We're going to make a complete new folder for it, calling STM32, if I can. Alright, I'm going to create a TXT here. What do we call it? Flow blower mapping. Blower mapping, that's the actual technical name of it. Test 2, take this here, save it, alright. Take this guy. Yoink it out. The other guy here. Steal the code. Come on. We have this garbage. STM. Where are you? Okay. MX. I need to open the. What's this? IDE. Sorry. STM. No, not this one. The other one. D. Where is this? I think here. Max, make you a project. Projects folder. Open the IDE, STM32, IDE. We'll ask, this is the first time I launch it on this PC, so I will turn this guy off. Stealing the code. I don't know, is it visible from here? I can check. So actually, oh, it's pretty okay. Sorry for the sorry for this. I should have probably come up from the PC. Mm, I'm not going to bother with changing for now. Sorry. All right. Yes, this is not okay. This is not okay. This needs to stop right now. Okay. Projects launch. All right. Till this launches. Oh, I've already put this. Okay. Fine. We will go through this anyways. How the fuck are we going to do this? Oh, that's the good question. Yes. Give it. The good question is, what did I do on the other one? Because I can't remember. Can't remember. Okay. Raw is very important. Alright. Electrically, okay. Important correction what voltage to use. Yes. This line is correct in principle, but the ADC difference really is 3.3 volt key point. No. Oh, okay. So it's supposed to be alright. What I will do is I will steal the actual code as well. I will steal the project folder as well. Okay, STM32, and we wanna steal the code for the project. This is very annoying. Come on. B STM projects, and it is called test2. I'm just going to steal the whole thing. Go on. Holy Jesus, 26 megabytes, what the fuck? A lot, actually. I mean, I do not understand why. Whatever. This is not too fast. I will read till them. No, I will not read till them. We have the code. We will disengage him from now. If I could. Put put here. We'll steal it and put it in here. Metadata, I do not care about that. I need to FE. No, I don't give a shit about this. I really hope I did not pull it out completely. I really hope I just didn't copy it. It would be too good if I did that. Though I mean, alright, not copy, just come on. Alright, IDE should be able to see this. Keep being scanned by Microsoft. I do not trust this. Alright, create import. Import next. Directory projects. Okay, test2 finish. Hello? Hello, motherfucker. What up? I think it's called project explorer. Yes. For some reason I can't see it. What up? Alright, core share C, main C. And here we have the guide. Let's go back and turn this off. So 3.3 watts is not bad. So do not replace. Yes, alright. Leave as it is. Okay, with the divider actual effects. The signal chain is sensor output 5 volt domain, divider X056, ADC, okay. Must compensate for this after ADC voltage conversion. This is the cleanest way. Yes, this is the divided voltage. We are going to call this div, if I can find it. Raw voltage, we're going to change this to div V. Div V, okay. Or div, whatever. No problem. Fuck. Just going to do this. Alright, take this, put it here. Alright. Oh, I will have to add something, I think. Project properties, it was, I think, build, settings, I think miscellaneous, oh, it's here. Oh, great. How the fuck does it know that? Alright, alright. So, actual sensor output voltage. So, we should actually divide this so that we can float. We put this here, this sensor, because I think this is supposed to be float. And we take the div and divide it by 0.65 and put this here. I think this is it, right? Oh, F, okay. I don't know, maybe float, maybe. Alright. Okay, what is the correct equation? V out is Vs. Rearrange for pressure. Okay. Pressure kilopascals. I don't think we need kilopascals. I don't think we need that. Kilopascals, no. No. Range Vs measures sensor supply voltage, 5 watts, but this V out is V sensor, yes. So let's read this. I'm a beginner as well, so I don't want to just copy paste it. I could actually to make a faster progress, but I don't want to. Alright, I will be able to print it here. So I think, what the fuck was this? So we need a equation which is float, maybe KPA, but I think we should go with the. This. Whatever, go with the KPA and then we will. It's just kilopascal, just in reference. Did he write it with big? No. He with KPA. We do. Fuck off. What do we do? We take. What's this? Whatever. Oh, fuck it. Because I don't know this equation. So we take this, not the Vs. What's Vs? Vs, what is Vs? Vs. Wait a minute. What? What?
What is this? What? V out, what is VS? 5 volts. So you divide it by 5. Measured sensor supply voltage. Yes. Oh fuck, I didn't measure the sensor supply voltage. Oh man. Yes, I know. I will have to measure that as well. Yes. I will finish the coding and I will go and do that. Yeah, the big problem that I'm seeing now is that I do not know what the VS is, because we need that, because V out is VS times this equation. Basically, this is for us to be able to convert the read the voltage immediately to pressure. This is like an equation for this shit, which is very useful actually. Just need to measure out the VS, which is the power supply of the pressure sensor, and how the fuck am I going to read that? I do not want to short the pins. There are like very little things. Measure sensor voltage. Put it together. Clean correct code. VRF, VS. Sensor supply measured. Yeah, he says it as well. Driver ratio. Yeah, divider ratio. Divider. VRF ADC. Okay. V sensor V div. Okay. And pressure V sensor VS return pressure. I do not know what this is for, but float ADC to pressure. Unit ADC. Put it together. Print. What is return does? I will have to learn about this more. I have no fucking clue. Return pressure. Pressure, but pressure kPa. What is pressure kPa? There is no pressure. Huh? Yeah, that's a problem. V sensor, V div, what did we call them? What are these? V div, V sensor, P kPa, pressure. Pressure kPa, and we gonna print F this. I don't know why he does this pressure, return pressure. What does return do? We'll have to ask. Whatever. Okay. And we have to add these ADCs, this loop, which is fine. We'll take this, this. Actually, alright. What do we have? V div, V sensor, V div, ADC, V div, V sensor, and pressure. Okay. Come on. Okay. V sensor. Alright, and this is going to be div. Divine. Okay. ADC V div. We put here. I know. What do we do? V div. That's fine. V sensor. And we put another one, which is pressure APA, if I'm correct. I don't know why this pressure. I think this is some sort of
float ADC to pressure. I don't know what this is. I have no clue. On the right, pressure. Here we put the 13F. Here just we put KPA instead of 0.5. Oh, is it fun? Here. It's like this. Maybe not. We'll see. Let's see if you build this shit. If you unfinished jobs, what up? Maybe this. Oh no, here. Something here is broken, which doesn't seem too nice. What's up? Waiting for unfinished jobs. VS uncleared. Oh, right. Of course. VS. VS. Let's go here. Let's go. I'm going to maybe. I'm going to call it here. I don't care. VS. Calling it. Float. Here another float. What is him? 5. Let's go with 4. Let's go with 5 volts, but I don't think he's 5 volts. Save, comply, hopefully it is good, nice now. Yes, we comply well. Great. Now I will. Yes, I will need to measure this shit. Baseline ADC 1.9000. Let's scale near 0 kilopascal. Harsh positive pressure divided. Did not ring resolution. 1000 consoles per excellent. Actual VS, actual VDDA on the ADC reference. Do not assume 5 volts or 3.3. How the fuck do we actual VDDA ADC reference? How do we do that? Complete the divider after. Compensate divider after use. Okay. Oh my god, damn it. I will send this, hopefully. I mean, this is the problem, that everything takes time. It's just like this. I mean, can I face myself here in the midst of chaos? So, it's always more effort, more time, and it takes more money than you think it is. And it's the same problem right now that I thought I was going to be able to even run a PMW test today, so that I can measure out the water height difference. I mean, I can show you if you are still here, whatever. So if we take our selves to the toilet, I have set up this little testing rig which have fallen apart, but I will have to redo it with the duct tape actually fallen out or fallen apart from the tiles. But this is the manometer that I have told you about, and basically what you have here is that you have a manometer which, as you can see, if you have a fixed starting point, they are going to keep their pressure difference because there is atmospheric pressure in here, and the water level difference is not going to change. But when you open them and vent them both, they will equalize out. in terms of height. And when you put the one port here on the manometer that I have drawn, you will be able to close them, and you will be able to push on one and pull on the other, create a delta H between them, measure out, because that is important to reference. And I will have to shut down my phone because I can hear already that the alarm is going off. All right, so back to the test. Where are you? So go back. Oh, I didn't change the what is this? This screen. I suppose I thought I was going to video myself rather than the fucking sim. Sorry. Very immature. So, good question. This is one of those STM special details that you actually matter for accuracy. Below are these 3 correct ways to measure VDDA, ordered from best acceptable frequency. Best way recommended: measure VDDA PNA directly with a multimeter. On STM32, look level VDDA is separate a supply pin. It's usually tied to 3 volts through a ferrite bead. So always exactly the same as VDDA. Fuck off. VDDA. I think I have seen this pin somewhere. VDD, but I think it's on the other side. I think it's on the other side. This is VDD. We need VA. What is this? Shit. VDDA. So dumbass codings. Fuck. It's not here. It's just VDD. VDDA is. I think it's on the other side. AVDD. No, on this one. Where are you then? VDD. AVDD. Oh fuck me, man. Where is it? Hello? I might be blind. Never find these. AVDD. Cam 1, don't care about these. ABCs. Cam, supposed to be red. E5 VDD, maybe this is it? VDD? Yeah, maybe that's going to be it. Maybe that's going to be it. VDD, separate analog supply pin, maybe that's it. Negative probe, positive probe, VDD. Oh! Maybe it's because the A means that it's on the A row, A side. That's why. But it's actually VDD. It's on the A pin. Positive probe on the VDD. So it's this actually, which is the E5V. Or next to the E5V on the other side of it. You'll have to put a male pin on it and I will measure out. I will fuck around with the E5V. This is this. I will take a ground pin and I will measure it to ground. Measure it to ground. Of course you are on the wrong side. H. I will measure this and I will measure the other thing as well, which is, how do we do this? Now I will change to actually this, which is the, I will change myself to here and do the more, I don't know, laborious work, which is measuring out the voltage. If I can pin. I'm thinking about, should I put it on? I will first go and measure out these pins. Need this. The good thing it would be to be able to do this. This is ground. This is VDD. I hope I do not fuck. 3. .0 volts, 2.99. That's not too good. Yeah, 3 volts, 2.99. Okay. 3 volts. 3 volts, 2.99. Alright, I believe that. Okay, and now we will measure out this. I'm thinking, how do we do this? Maybe I can measure out this, and I can put this onto the other leg. Maybe I should do this with the right hand, because I'm right-handed, not a lefty. Lefty. .87. Right, 4.87. The other one was 3. Alright, we have everything that we needed. We actually still leave him here connected, because I will now upload the code. Take out disconnect him quickly. Remove the pins. I don't want to do. Oh, was it not correctly connected? I will have to redo this. No. Do this again. I'm pretty sure we did it right, but make sure it's okay. I'm not convinced with these fucking DuPont wires. I'm just very annoyed with these. They, I always tell the story, but like one time I had 2 days because of them. I was actually spending 2 days because one of these dumbass DuPont cables was actually loose. Even though it was on the pin, it was not providing it with supply voltage. 3.03 now. Very interesting. 04. 3.03. I don't know what happened from the last time. 3.05. 6. What the fuck? 3.06. 7. Are we going up to 3.2? 3.07. 06. 3.05. This is not it. Whatever, I'm going to call it 3.06. Fuck you. Now, what? Come on, man, what is this? This is a joke. I have moved it on the pin itself and it went down to. It's 3 watts, 3.01. What? What? If I measure here, it's 2.97. If I measure here, almost next to the base of the pin, it's actually higher. 3.12. Yeah, let's go with 3.12. 3.12. Interesting. If I put it here to the end tip, almost to the tip, it goes down to 3. If I pull it up, I mean, maybe I should put it here because then it would be actually similar as to the other thing. Close to the whatever. I'm going to log both. So it's 2.88 like this if I measure here, or actually if I measure here it's 3.0 3. Okay, I will go with that. 3.03, 3.00. Let's go with 3.0. Okay. Fucking dumb, like, this is so dumb. If I measure at the end, then it is 4.867. If I measure at the, or the tip, if I measure at the end, it might be 5 volts. Who the fuck knows? Whatever, going to do it. Come back into this lovely STM32 word, and then we will do this. Now I can't turn this out. Do the very, very handy, lovely. Expected value all right, so I suppose we are back. Unfortunately, I have unplugged the streaming phone, and the very unfortunate thing is that with this phone is that it has a very shit battery and it died. And I have now, I think, 5 or maybe 10 minutes. I have only now was able to actually notice it. So I will still record this shit. No, but this is Adoptium. What the fuck is this? Yeah. Alright, we have this. Fine. So, yeah. Alright. Not this. I think this is so annoying. Alright, fine. Current loop is doing several things redundantly, incorrectly. Really nice. Yes, not 3.3F. Okay. Replace editor in the new file. We have to find the. Where's this shit? I was actually looking for UART sampling 16. And this. Ah, here it is. Okay, that's good. Okay, that's great. That's great. Yeah, this code is a mess. Printf, this is starting. What is this? Where are you? Oh, I didn't save it. How good is this? Oh, great. Lovely. Oh my fucking god. Whatever. What is this shit? Whatever, I'm going to read this, then I'm going to edit this. Yeah, this is just autopilot. I have no clue what I'm doing. I'm editing this. I will have to learn this shit later on. I'm just too fucking tired to understand any of this. Updates. Very nice. Computer UV sensor pressure, 0.19 per sec. Main C. You can paste this into main C. Yes, single channel graph int right. Is this the put in? Oh, this is the user code 0 begin. Does fuck off. Does this have the right? Yes, this have the right thingy. This, because this is very important. Alright, very big cock here. Wait, save quickly, because it will forget this shit. While started, alright. Resensor, okay. Duration, okay. Float VDA 3F, fast VDA MS 0. Hull get tick. Okay, and hull delay, and we're going to just fucking replace the whole thing. Where are you? Hull int, okay, ADC started, while going to just spit on this float. I might just do it. Just going to say hello. Hello, motherfucker. Right, so this sets the to 3.3 volts initially, but I think it's going to read it, and it's going to now last 3 dBA. Okay, and this is 0, the ratio. Let's see if this works. Build. Hope it works. Has 2 warnings, but it seems it works. Alright, we can put this garbage onto the guy. Config channel. VREF int call address. Commonly used. Okay, we'll see this. What the fuck is this? STM32, not pinout, but what is this? Manual, datasheet. Cortex. This is the boom. Alright. VREF int. Bitch. Oh, please come on. Oh, memory address. Here it is. What is this? F7A2A. Yes. Or AB. 1X FF7A2A. Right. Great. Okay. Okay. Replace the hard-coded with a measured value if you want. Or measure it once with multimeter, keep it constant. This is it, I think. It's the simple moving average 520 samples on ABC reduced to traffic. Alright. Alright. So now we put this guy into the, put him up, put the code up onto the guy, IDE, and now we flash him, hopefully. Alright. Debugger. Launch putty in the meantime. I have to find which serial port it is banished to, because I have no fucking clue. Comfort still, alright. 1.5,
how is it? One, I'm just so brain that 1152222, yes, serial, okay, comfort, open. Okay. We have div 1.4 volts, V sensor 2.5. That's pretty good because it's supposed to go 2.5 volts. I think this is pretty good. Yeah, what is this? 100. That's a bit problematic because we have nothing. We have no differential pressure and we have like point. Oh, it's pretty stable. 88 to 101. It seems like 88 to 103. 5. We will have to leave that as baseline because the then we will basically measure like 200. What was it? Yeah, it's about 10 at like 100 pascals to 400 pascals. It's not going to be a lot good if we have 100 fucking pascals of deviation. I mean 11, 20. Yeah, 20 pascals, that's like 20%. That's not too good, I mean, to be honest, in terms of deviation, if we measure. That's not too good. Yeah, we'll have to measure, average them out. $99, $96. I suppose if we don't take the outliers, then we are pretty good. 99, 98 till 100. I don't know what. 99, 102. Yeah, there are like some deviations in there, but I suppose the gross average is about 105 and 90 something, so 10, 10%. Still not the best. Baseline. I think 89 was this like the lowest, but yeah, I would say 80, 90, 110, but most of them are around point 97, point 105, something like that. So yeah, 10, 7. I think yeah, around that. So I think a 10 deviation. But I think it's pretty good. It's pretty good. In terms of voltages, is it the 27, 37, 40? I mean, could be better, but like, didn't expect much more of this. It will be probably a bit better if we are going to, I mean, I'm not totally sure, but we will see. I will say that. It's actually 9:40. Oh my fucking god. I mean, I have flashed this, and I'm pretty happy with what I have achieved today. I will put the devices that where they're supposed to be, and I will continue from here tomorrow. I will do that tomorrow. I will make a bit of a little bit. Don't fall over this shit tomorrow. Okay, put here. Put the knife over here. Yeah, I think pretty solid day. Pretty solid day. Pretty solid day, man. Pretty solid day. Great, great, great. Alright. 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 So I'm just going to log out exactly right now. So you caught the last minutes. I will just log the fuck out. I have made the, I mean I can pull, oh come on, whatever. I will pull the things, I mean not apart, but sort of put them somewhere a bit to the side. Okay, put this with the board to here maybe. Please don't do it. Don't do it. Alright, we have everyone here. Great, great, great. Push him a bit to the side. I'm just going to fucking be asleep again. Oh, come on, man. I'm a dumbass. Fuck. Yeah, I should fucking stop these. Whatever. So, yeah, do the hard work, especially when you don't feel like it. So, thanks for watching. Yeah, goodbye. Ah, goddamn.